In the past several videos, what we've taken a look at is how we can actually compute probabilities with a binomial distribution and ultimately kind of progress through this column in the formula sheet. The last thing we have to talk about is down here in the parameters box underneath the binomial distribution. When asked, we might need to be able to go ahead and compute the mean and the standard deviation for our random variable, just like we did back in the previous section. However, in the previous section, we typed in an entire table worth of information into lists in the calculator and ran a 1-var stats. And while we can do the exact same thing with a binomial distribution, it's much easier to instead use the following shortcut formulas that work specifically for the binomial distribution. So, if I go back here, you can see that since these formulas are so simple, we can go ahead and compute this almost without the use of a calculator entirely. Let's see. In example 2, our question here is going to be, what was the average number of customers that we would have expected to sign up for a credit card? Now remember that when we see that word expect, we automatically are thinking that, oh yeah, that means I'm looking for an average. And according to the formula up above, I would just have to take n times p. Well, n was that there was 8 customers, and p was 30%. Now, this calculation here is going to produce a total value of 2.4, and my units on there would be customers. I would expect about 2.4 customers to sign up for a credit card. Now, overall, this really shouldn't be that surprising, because again, if 30% of individuals sign up for a card and we had 8 people, isn't this exactly what we would expect to happen? Seems like it. Well, let's take a look at the standard deviation now. The standard deviation for the number of customers who will sign up for a card can be found by computing the square root of value of n times our value of p, so that's 8 times 0.30, and then I'm going to have here 1 minus p. Well, notice that if p is 0.30, then 1 minus it should just be 0.70, and so I'll just simplify that down right there. Now, if I was to go type all of this in the calculator, and I could crunch out a final value, I think what I would end up with here is a square root of 1.68, which, when rounded off to 4 places, is 1.2961. And again, the units here is customers. And again, we should be able to kind of interpret this value. Remember, what we're seeing here is that we have our average of 2.4 in the middle, and then our standard deviation is how much we should expect is pretty common to go above or below average. And so it's pretty typical to find or to have a number of customers that sign up for cards be somewhere within this range. So we say here that it is not uncommon to find the number of customers who sign up for a new card to be within 1.2961 customers from the average. Now again, there's lots of different ways you could word that sentence. You could find these values at the end and the beginning of this interval. I think if you were to actually go ahead and do the addition and subtraction, you could find that this lower value is 1.1039, and this upper value is 3.6961. So you could also say it's not uncommon to find the number of customers who sign up for a new card to be between 1.1039 and 3.6961 customers. So this is how I can calculate the mean and standard deviation for a binomial distribution.